Hello friends, I welcome you all in this session. As you are aware, in previous session we were discussing about two sample hypothesis testing, and before that we did work out couple of examples using Minitab on one sample hypothesis testing. So, let us look at some more examples on two sample hypothesis testing, and we will work out those examples using Minitab as well. So, this is the question which we worked out in previous class. We wanted to know in which share market or in which stock exchanges you would like to invest in. So, we did compare mean of these two stock exchanges, and we said that the null hypothesis is that the mean returns from these two stock exchanges would be same and it would be different, the alternative hypothesis. And we have said that calculated t value is outside non rejection region, this is your non rejection region. So, we will reject null hypothesis, right. Now, we are rejecting this null hypothesis and we are saying that the mean return from these two stock exchanges is not same, it is different, right. So, different means in one of the stock exchanges return is higher, right. So, in which stock exchange return is higher? It is in New York Stock Exchange, because sample mean is higher than sample mean of Nasdaq, right. So, let us work out the same example using Minitab and let us see what is the conclusion there, right. So, here we are rejecting null hypothesis, right. So, let us look at this question and you just keep in mind the number over here, sample mean and standard deviation of these two. So, we will work out this example using Minitab, right. So, we will go to stat first, basic statistics, and then we will go for two sample test, right. So, in fact, there is something called two sample t test. In fact, there is in this particular software there is nothing like two sample z test. In fact, it calculates t test even for larger sample size. So, we will go at two sample t test, right. Since in our case if you look at sample size, then the first sample has got size 21 and second has got 25. So, it would be a case of t test, right. So, you can have both samples in column or you may have each sample in its own column, and otherwise you can have summarized data, right. So, we will click at summarized data, sample 1, right. So, we have to enter sample size for sample 1 and that value is 21, right. Then we need to write sample mean is it is 3.27 and standard deviation is 1.30, right. Similarly, you need to enter data for sample 2, right. Sample size here is 2.53 is sample mean and standard deviation is, let us look at, it is 1.16, right. Now, after making all these entries, go to options, then you need to test this hypothesis at 95% significance level. Hypothesized difference is 0, right, because we are saying that the returns are same from both the stock exchanges, right, and alternative hypothesis they are not same, right. So, this is not equal to type. Assume equal variances, that is our assumption that this the populations from where we are drawing samples, those populations have got equal variance. Then we will click OK and OK once again, right. So, let us look at output. Here output is, if you look at null and alternative hypothesis, in fact the difference we are saying is they are same, right. Mu 1 is equal to mu 2. In fact, here it is written mu 1 minus mu 2 is equal to 0, which is as good as mu 1 is equal to mu 2. Now, the p value over here is 0.045, right. Keep in mind it is 0.047, right. And what is the value of alpha? So, this p and alpha is equal to 0.05, right. So, is p value less than alpha? No. So, we will not reject null hypothesis, right. And this is the same conclusion which we found in critical value approach, right. So, we will not reject null hypothesis by looking at p value, and the similar was the conclusion. So, in fact, okay, just look at this once again. So, p value here is 0.047, p is 0.047 and alpha is equal to 0.05. So, p is less than alpha. So, in fact, it was my mistake. So, p value is less than alpha. So, we will reject the null hypothesis, right. So, the decision is reject null hypothesis, right, not the non rejection of null hypothesis, right. So, we will reject null hypothesis because p is less than alpha, right. So, either you go by p value approach or by critical value approach, will reject null hypothesis, right. So, let us look at some more examples. In fact, this is the table which we have seen in previous example as well, when we solved that question using critical value approach, right. So, let us look at one more example. Is there any difference between earnings of students of two IITs? Check this at 0.05 significance level. So, let us say you have got mean earnings of students of IIT, let us say Bombay or and IIT Roorkee, right. So, after selecting a sample of 200 students, their mean earning was let us say 8.95 lakh per annum, and this is after selecting 175 students, this is 9.10, right. And after calculating mean, we also calculated standard deviation of these two samples, right. So, we want to know, is there any significant difference between earnings of these two students of IIT Roorkee and IIT Bombay, right. So, what should be the first step? The first step is you need to frame null hypothesis and alternative hypothesis, right. So, what would be the null hypothesis? The null hypothesis is that there is no difference. So, mu 1 is equal to mu 2, right, and of course, alternative would be mu 1 is not equal to mu 2, right. So, this is what type of test? It is a one tail test or two tail test? It is a it is not one tail test, it is two tail test, because this sign is not equal to type, right. So, we will have two rejection regions, and if you look at the sample size over here, both these sample size are more than 30, right. So, the appropriate statistic would be what? Would be Z, right. So, when we apply Z statistics over here, so this is how you can calculate Z statistics. So, this is the difference between these two samples, sample means, and we are saying mu 1 minus mu 2 equal to 0. So, this term is 0, right, and divided by difference of standard error of mean, right. So, this is under root of sigma 1 square divided by n 1 first sample size, then this is sigma 2 square divided by sample size of the second sample, right. We have to test this hypothesis at 0.05 significance level, right, and using critical approach method, if you want to solve this question. So, for critical value approach, we know that the Z table value would be what? at 0.05 it is 1.96, right. So, you have got all these information over here. So, you have got x 1 bar minus x 2 bar, right, difference of these two, this term is 0 and you need to just calculate the difference of these two standard errors of mean, right. So, when you solve this question, this term is equal to 0.053, the estimated standard error is 0.053 and z value is this. So, calculated z value is minus 2.83 and the table critical value is 1.96 plus and 1.96 minus, right. So, the calculated t value is z value is in rejection region. So, we will reject the null hypothesis, is not it. So, we will reject the null hypothesis. What is null hypothesis? That there is no significant difference in the earning of these two groups of students, right. So, we are rejecting it, means there is a significant difference, right. So, when we say there is a difference, it means which group has got higher salary, this group, right, because mean is higher, sample mean is higher over here, right. So, let us look at, we will work out the same example using Minitab, right. Okay. So, let us look at Minitab and work out, we will work out this example. So, this is a case of again two sample, we do not have any option of z test. So, we will click at two sample t test, right. So, we have got two samples. So, the first sample, it is sample size is 200, sample mean is 8.95, which is here, right, is not it. Then standard deviation is 0.40, right. Similarly, we will make entries for sample 2. So, sample size is 175 and 9.10, sample mean is 9.10, right. Let us look at standard deviation, I think it is 0.60, yeah, it is 0.60, right. We will go to options. We have got significance level as 0.05. So, this is 95% confidence level, hypothesized difference is 0 again and alternative hypothesis is again same, there is no difference between these two groups, right, and we have to assume equal variances. So, we will click at OK, again OK, right. So, p value is this 0.004, right. So, p value is 0.004, alpha is 0.05. Is p less than alpha? P is less than alpha. So, we will reject null hypothesis, right. This is the conclusion we are drawing from probability value approach, and this was the result using critical value approach, right. Results are same, right. So, you can work out an example like this using Minitab as well and you will get the same answer, right. So, let us look at one more question. Two independent samples of observations were collected. For the first sample of 60 elements, the mean was 86 and standard deviation was 6. The second sample of 75 elements had mean of 82. So, if you look at this, in this case sample size 60, mean is 86, sample size 75, mean is 82, right. and standard deviation 9, right. So, what we have to do? First of all, compute the standard error for difference between these two means. So, this is what we calculated in previous example as well, right. This is what we have to calculate, right. So, this is what we are supposed to calculate, right. And then using alpha is equal to 0.01, test whether two samples can reasonably be considered to have come from population with same mean. So, our null and alternative hypothesis what would be what? So, your null hypothesis is that these two means are same, right. This is your null hypothesis, and alternative hypothesis is that they are not same, right. So, you can solve this question using critical value approach. So, for this alpha 0.01, we need to look at the table value, which is actually 2.58 in fact. So, it is 2.58, right. So, 2.5 and 8, this is the one, right. Let me delete this first. So, again let me tell you where that value is, right. So, first of all 0.01, right, is the alpha, right. So, what you are supposed to do? It is 1 minus 0.01, right, 0.99 divided by 2, right. So, whatever is that value, you have to find out z value at that probability, right. So, that value is at 2.58, right. So, 2.5 here, this is the one, right, 2.58 I think, no, this is the one, 0.4951, right. So, 0.4951 is basically nothing but 0.99 divided by 2, is not it. So, that is your table critical value, and what we have to find out is this, right, in the first part of the question. So, this is very simple, you just put values of n1 and n2 and sample standard variance, right, variance of these two samples, right. Since you have been given standard deviation, you just take square of this, right. So, S2 is this, S2 square is 81, right, S1 is 6, S1 square is our variance is 36. So, it is 1.29. Okay. Now, when you look at z value, when you calculate z value, this is the difference you can easily calculate. So, you know this 86 minus 82. So, this term is 4, right, this term is 0. So, 4 divided by 1.29 is 4 divided by 1.296, you will get 3.09, right. So, if you draw a distribution for this particular example, you have got these two rejection regions, right. This is also rejection region, and this is 2.58 minus this 2.58 plus, and your calculated z value is what? It is 3.09. 3.09 means this side somewhere here 3.09. So, what will you do? Will you reject or will you not reject null hypothesis? You will reject null hypothesis because z value is in rejection region. Okay. So, we are saying that we will reject null hypothesis and we will conclude that it is reasonable to conclude that the two samples come from different populations, right. They do not come from same population, that is our conclusion. Now, we will look at the same example using Minitab. So, let us look at data first. So, it is 60, 86 and 6, right, 60, 86, 6. So, we will go to stat basic statistics, yes, two sample t test 60, 60, 86 and 6. So, these were the information given about sample 1, right, 60, 86, 6. Let us look at sample 2. It is 75, 82 and 9. Right. Now, you need to click at option. Since our alpha is 0.01, so this is at 99, right. Hypothesized difference is 0 again, and of course, alternative hypothesis is also given as there is no significant difference, right, and we are assuming equal variances. Let us click at OK and again OK. So, p value is 0.04. Is this less than alpha? 0.004. 0.004 is our p value and alpha value is 0.01, right. So, we will say that p value is less than alpha. So, we will reject null hypothesis, right, which is the decision we have taken here as well when we used critical value approach. Now, in this example, let us look at this. In 2013, the Financial Accounting Standards Board was considering a proposal to require companies to report the potential effect of employee stock options on earnings per share, EPS. So, what FASB did is they collected 41 high technology firms data, revealed that the new proposal would reduce EPS by an average of 13.8% with a standard deviation of 18.9. So, FASB collected data from high technology firms and the mean was 13.8% and standard deviation was 18.9%. A random sample of 35 producers of consumer goods, right, these are some different set of companies, right, consumer goods, showed that the proposal would reduce EPS by 9.1% on average with standard deviation of 8.7%. On the basis of these samples, is it reasonable to conclude that FASB proposal will cause a greater reduction in EPS for high technology firms than producers of consumer goods? So, here let us call mu 1 as high technology firms mean and mu 2 is mean of consumer goods companies, right. And what is our null hypothesis? It would be mu 1 is equal to mu 2, right. And alternative hypothesis would be what? Proposal will cause a greater reduction in EPS for, so mu 1 is less than mu 2. This is our alternative hypothesis. Now, we will work out this question, right. Now, if you see this question, then here sample sizes are more than 13 both the cases, right. You have got 41 and you have got 35, right. So, we will be applying again a Z test, right. So, we need to calculate critical value approach first. So, for critical value approach at 0.10, so it is 0.9 divided by 2, right, it is 0.45. So, look at the value of Z when area under curve is 0.45. So, 0.45 area under curve is, so this is somewhere here, right, 1.64, isn't it. So, we will say that the critical values here are plus 1.64 and minus 1.64, right. Okay, it is not 1.6, it is 1.28 actually. So, let us look at what is there, 1.2, 1.28, right, yeah, this is 0.4, and in fact, this is this is the one tail test. Yeah, that is why this, had it been a two tail test, this would have been the value of z, but since this is a case of one tail test, right, and which is again a left tail test. So, the distribution would is like this, right. So, this is your rejection region, right, and this is your mean, right. So, that is why we know that this area is 0.5, this area is 0.5, right. So, why we are looking z value when area under curve is 0.4, because this is our significance level is 0.10, right. So, this is 0.5 minus 0.1, it becomes 0.40. So, look at 0.40 probability in this table, which is here, right, it is 1.28. So, the first part will remain same, this is the difference in standard error. In fact, this question, in fact, if you look at once again, then this is in fact what we are, in fact what you need to do is, let this be a consumer goods, this be a high tech one, and this be a consumer goods, right. So, we have to just reverse it, right, rather than having it a less than type, you can get it alternative hypothesis like this, right, a greater than type, right, because we have to see that the proposal will cause a greater reduction in EPS for high technology, right. So, reduction is more in high tech compared to consumer goods. So, you need to reframe your null and alternative hypothesis like this, right. So, mu 1 and mu 2 are equal and mu 1 is greater than mu 2, right. So, this is an upper tail test, of course instead of this, now this is your rejection region, right. Let me repeat it, let me erase everything first and let me redraw distribution, how distribution would look like. So, this is your distribution and this would be your rejection region, one tail test, right. So, mu 1 is greater than mu 2. Okay. So, after calculating standard error difference, which is 3.92, find out value of z. So, this term is 0, x 1 bar minus x 2 bar, which is this 13.8 minus 9.1, right, divided by 3.92. So, this is equal to 1.43 and z value is 1.28, right. So, this is how you should be drawing your distribution. So, this is your 1.28 and this is your rejection region, right, and calculated z value is somewhere here, right, which is 1.43. So, you will reject the null hypothesis, and when you reject the null hypothesis, it means you are accepting alternative hypothesis, and it means that the proposal will cause a significant greater reduction in EPS for high technology firm. So, whatever you are assuming in this question is correct, right. So, this is how you can solve this type of question using Minitab as well. So, let us look at how to solve this question using Minitab. So, we will go to stat first, basic statistics, then 2 sample t test, we will enter data. So, let us look at our data. So, you have got 41, 13.8 and 18.9. So, 41, 13.8, 41, 13.8 and the third one is 18.9, right. Let us look at data for sample 2, it is 35, 9.1 and 8.7. 35, 9.1 and 8.7, right. Let us look at options. So, options, this we have to test at 0.10, it means 90%, right. It is 0.10, it is not 0.01, right. So, the alternative hypothesis is greater than type, yeah, right. So, it is an upper tail test, okay, and again okay, right. Let us look at p value. P value is 0.091, 0.091, 0.091, right. This is p value and alpha is 0.10, right. So, p is less than alpha. So, p is less than alpha. So, we will reject the null hypothesis. This is what we concluded in critical value approach as well, right. So, with this let me stop here, and in next session we will work out couple of more examples on 2 sample test for proportion as well, not only for mean. Thank you very much.